Today's video will cover rotational motion examples, and this is intended for AP Physics or Physics students. Our first example states that a disk of 30 centimeters is spinning at a constant angular speed of 10 radians per second. The first part of the question wants to know how many radians has the disk covered in 10 minutes. So for this, we're going to use the formula theta equals omega t, which represents the angular position, omega represents the angular velocity, and t represents the time. So we will plug in 10 radians per second, and we're going to multiply that by the time in seconds. However, this gives us the time 10 minutes. So 10 minutes is going to be equivalent to 600 seconds. So we're going to plug in 600 seconds. The seconds cancel out, and that's going to give us a total of 6,000 radians. And that answers the first part of the question. The second part of the question wants to know how many revolutions the disk has covered in this 10-minute period. And similar to how we solved the last problem, we are going to use the 6,000 radians. And we want to convert that into revolutions. So 2 pi radians is going to equal 1 revolution. The radians cancel out, and then we are going to divide our 6,000 by 2 pi, and that is going to give us 954.93 revolutions. And that is our answer to part 2 of the question. And the last part of the question wants to know how many meters the disk has covered in this 10-minute period. So we are going to convert our 6,000 radians into meters, and we're going to use the conversion factor 0.3 meters over 1 radian. And we can do this because we first need to convert centimeters into meters, which is 0.3, and radians will cancel out. Once you multiply 6,000 by 0.3, you will get 1,800 meters as the distance covered in 10 minutes. And that's your answer to part 3. Now this problem is a little more complicated. It states a wheel with a radius 10 centimeters accelerates constantly at a rate of 5 radians per second squared. And the first part of the problem wants to know how many revolutions the disk has covered in 20 seconds. So we are going to find that by using the formula theta equals omega initial times time plus 1/2 alpha, or angular acceleration, times the time squared. And since this is accelerating from rest, this will be 0. So we're going to plug in all the information we have, and that would be theta equals 1/2 the angular acceleration being 5 radians per second squared times 20 seconds squared. And that will give us 1,000 radians. And now that we have our radians, the last part's really easy. We want to convert that to revolutions. And we know that 1 revolution is equal to 2 pi radians around a circle. The radians are going to cancel out, and we will divide 1,000 by 2 pi to get approximately 160 revolutions. And that is going to be our answer to part 1 of this problem. The second part of this question is a little trickier. It says, what is the linear velocity of a point at the edge of the disk after 20 seconds? So to solve this problem, we are going to use the formula final velocity equals the final angular velocity times r. And our problem is that we do not know what omega final is. So we need to calculate that first, and we can do that using the formula omega equals alpha times the time, where omega equals the angular velocity, the alpha equals the angular acceleration, and t equals time. So we will plug in the information we know, which is alpha equals 5 radians per second squared, and the time is 20 seconds. This will give us a total of 100 radians per second. And we can use this for omega final. So we will have 100 radians per second, and we're going to multiply that by 0.1 meters over 1 radians, and that will be our conversion factor. We can do that because we have the information of 10 centimeters, which is equivalent to 0.1 meters, and we'll add radians down there so that way our radians cancel, and that will give us 10 meters per second as our answer to part 2 of this problem. And our last part of this video states, a disk with a radius 3 meters has covered 4 radians. What linear distance has a point on the edge of the disk traveled? So we're going to use the formula d equals theta r. And d is going to be our linear distance. Theta is going to be the radians, or the angular position distance it has traveled, and r is going to be our radius. So we are solving for d, and this problem gives us all the information we need. So we'll plug in 4 radians here, and for r we will say 3 meters over 1 radians as a conversion factor because the radians cancel out, and we will get d equals 12 meters.